In this video, we are going to go over how to convert numbers into scientific notation and how to take numbers that are in scientific notation and convert them back to standard form. In order to understand how scientific notation works, we need to understand how it is that our numbering system is what we call a base 10 numbering system. So if we have 10 to the 0, that's going to equal 1. If we have 10 to the first power, that'll equal 10. If we have 10 squared, that equals 100, and so on. So each time we go up by a power of 10, we increase by one digit. And so we have a base 10 digiting numbering system because each digit represents a power of 10. Similarly, with going up in exponents, if we go down in exponents, we get a similar effect. So if I take 10 to the negative 1, that's telling me that I am dividing by 10 one time. Well, as a decimal, that's going to equal 0.1 or 1/10, the tenths place. And so when we go down into our negative exponents, we essentially go down into our decimal place values. So we get that 10 to the negative 2 equals 1 over 100, which equals 0.01. And then we can just keep going in similar fashion. So 10 to the negative 3 is 1/1000th, but for what we're doing with scientific notation, we want to recognize that as being in the third decimal place. So 10 to the negative 3 is in the third decimal place. So as we go down, we're going down in place value. Now if we look at this with a number that isn't just a 10, we can start to see how it can work. So let's say I have 2,300. Well, I can start associating decimal place values with multiplication by 10. For example, this equals 230 times 10, or I can make it 23 times 100, and I can press on and make it 2.3 times 1,000. So basically, depending on how many powers of 10 I shave off, it shifts what the first number is in terms of place value. It doesn't change the 2 or the 3, it just changes what place value they end up in. Now each one of these 10, hundreds, or 1,000 I could write in exponent form. So the first one is just 10 to the first, so I left that alone, but you could think of the second one as 23 times 10 squared, or the next one as 2.3 times 10 to the third, and I could even go on down to 0.23 times 10 to the fourth. But this is how we convert stuff to scientific notation, but since there's options like this, there's a question of, okay, how many powers of 10 am I going to shift it by? There's some rules that are needed for scientific notation. Alright, so the rule is, and this is kind of my wording of it, but scientific notation has one and only one digit of value in front of the decimal. So, for example, if there's not a decimal, the decimal place is right there, right? So this number has 2 digits of value in front of the decimal. Up here, we would say there's 3 digits of value. This one has 1 digit of value. And if we went on down to the next one, the reason why I say a value is because if I wrote the next one, so I shifted another power of 10 over and I got 2.23 times 10 to the fourth, this, you could argue, it has digits in front of the decimal, but they don't have any value. They don't lend value to the overall number. So in the end, this guy here is the one that's written in scientific notation. They all equal 2300, but the one with the one number in front of the decimal is going to be the scientific notation. Alright, so now that we see that, let's look at an example. We're going to write this number in scientific notation. Now, every time it looks like we're moving the decimal, but what's really happening is we're dividing off powers of 10, and each power of 10 that we divide off represents a place value. So we need to get our decimal here. so that we have that 1 and only 1 digit in front of the decimal. So we're going to have to, all these other place values are going to be powers of 10 we shave off. So there's a total of 8 of them there. So this becomes negative 4.35 times 10 to the 8th. Because each one of those place values that we shifted represents a power of 10, and there are 8 shifts that took place. And people talk about that we're moving the decimal place. So it's like the decimal's here and we're moving it over, and sometimes people even draw loops. It's not moving, that's an optical illusion. We are dividing off powers of 10 and expressing them separately. So if you enter in your calculator negative 4.35 times 10 to the 8th power, it's going to equal the original number. So we haven't changed the number, we've just written the powers of 10 off separately. Let's look at another one. Alright, let's look at 0.000087. I think I said the right number of zeros. So in this case we're working with a really small number. The rule stays the same. So I know my front number needs to be 8.7. And then I'm going to have times 10. I just need to figure out what the exponent's going to be. Now in order to get up to 8.7, what I need to do when I shave off these powers of 10 is I'm moving in the other direction, is how it's normally talked about. But really what's going on is each of these place values that are below 0 represent division by 10. And so in order to shift the decimal in that direction, we're dividing by 10. In this case, we're dividing by 10 5 times. So it's going to be 8.7 times 10 to the negative 5. Now, again, if you want to think of it as moving, I'm not going to fault you for that. It's just that's an optical illusion. It's not really moving. We are dividing by 10. So the reason why I like to emphasize that is sometimes students like try to just memorize, if I move this direction, it's this way, and then they don't, if you don't know what the math is going on, then you'll kind of get the direction wrong or get your sign wrong on your scientific notation. So the idea here is if I take 8.7 and divide it by 10 5 times, I'm going to end up with a small number. If I take 4.35 and multiply it by 10 8 times, I'm going to end up with a big number. So if you think about it that way, then you won't get it backwards whether or not your exponent should be positive or negative. Okay, so that is starting with a standard number and converting it into scientific notation. What we need to look at now is going the other direction. Alright, so to write in standard form, let's start with negative 1.2 times 10 to the negative 3. So again, like I was talking about before, if we take negative 1.2 and this is saying divide it, we divide it by 10 3 times, that number is going to get smaller. So when we're writing in standard form, we are essentially doing the math that's right here in front of us. So I'm going to take negative 1.2 and times it by 10 to the negative 3, or divide it by 10 3 times. So what that's going to give me, now this one, because the number isn't written out long form, you kind of have to figure out what that means. Well, I'm basically going to gain, my place value is going to shift 3 slots. So I'm going to need, one of those slots is the one I already have. I'm going to need 2 more to get my decimal in the right location, and the number is going to stay negative. That's not going to change. That negative is just out there to kind of maybe mess you up just by a careless error. So I like to write this all clean in the end. So if you're using like little chicken scratch to help you know where to put things, clean it up and so your final answer is clean. But we get negative 0.0012. So if we think about our original number and we wanted, like, so if I wanted to take this and put it in scientific notation, I would divide by 10 once, divide by 10 twice, divide by 10 3 times, and I'd get back to where I started. Alright, now let's do 2.7 times 10 to the 10. If you want, you can pause the video and try this one on your own and then see if you agree with the answer that I'm going to give in about a second. So it looks like we're getting 27 billion, or 27 with 9 zeros after it. One of the things that people will do that is wrong thinking is they start to associate the exponent with the number of zeros, and that's just bad. That's not the rule. The exponent tells you how many times you're multiplying or dividing by powers of 10, therefore how many times the number is shifting in place value. But those place values don't necessarily have to end up as zeros. Alright, go ahead and give some of these a try and see how you fare.